So don't clump the thing.
Should I move them to the room or something?
Sorry?
Should I move them to the room or something?
Ah, yeah, I guess so. Yeah, probably a good idea.
Maybe just go grab a tote bag out of there and fill a tote bag up instead.
Sorry?
Just fill a tote bag up with all of them. So this you guys are people from today? Or
No, these are for us. These are from Woodwork.
Oh yeah, that's right. We were also there.
Yeah, yeah. Yeah, so we are here for one, I guess.
Yep.
Yeah, not sure if they're glass or if they're plastic.
The glass.
Could be very dramatic if we got all of them.
There is actually transparent aluminum.
How are you going, Ray?
Not bad yourself.
Yeah, pretty good. Pretty good. Busy.
That's good to
So
hear.
is everyone, I guess, you know.
So members in the
Oh,
group
sorry,
invested
you
in
need to know
crypto
whether
later
it's
is following the
stable
surge.
or not.
Yeah, well, I've got all of about $20, and it's funny, I've given, I set up a cryptographic puzzle problem for my nephew, so he's doing quite maths at QUT. So I thought, alright, well, 18th birthday present, here's a cryptographic puzzle, here's your private key, you know, so I gave him a piece of paper, you know, don't show this to anyone, this is money, you know, here's your private key, here's the address of a contract, go for it, you know, and by the way, the source code's here, you know, and so, you know, she just needs to go from private key to public key to an address, and then have a look at the code and go, alright, so what I need to do is work out a number which when hashed with my address will equal 0. So, you know, and then modulo, and it's 2 to the 16 plus 1. So he only needs to try 65,000 combinations. So like writing a bit of code that's about this long, you know, and boom, you've got $20. And it will only work for his, a private key. But I've got the private key too. So I'm sure if the ether price goes to, I don't know, 100,000. If it turns into $1 million or something, I'll probably I'll use the private key myself and get the money out. But yeah, it is interesting how we've gone up.
It's insane. Well, I was looking at the things,
Hey Peter, hi.
the history, and I predicted about June or July that there might be another little cycle will come through. It's about 2 months earlier.
Yeah, I would never try and guesstimate what's, I mean, for me, you know, we're using the platform to do things, and if other people want to do cryptocurrency stuff, well, good luck to them, you know? Yeah. But yeah, so we've got a conference that we've organised. Yeah, supply chain on blockchain. And so the idea of the conference is to try and get people from, you know, industry, academia, legal, you know, technology, supply chain people and blockchain people who are, you know, it's two completely different worlds, and yet, you know, all the blockchain people say, hey, this is going to solve all your problems, and all the supply chain people say, I'm not so sure.
Well, yeah, I mean, there were some things with sort of like some of the blood products that CSIRO got caught out with that would have been mitigated. I think there's some container mob that.
So there's logistics that it can help with, and there's supply chain financing, and there's
The
obviously
diamonds.
there's the diamonds and essentially provenance where the stone come from to try to trace, and automatic deal negotiation. And so the conference at the moment, the call for speakers is open, and so I'll talk about it right towards the end, but call for speakers is open until June the 10th, and the conference is on Monday, July the 15th at Fishburners event space.
Okay.
So so just off the Queen Street Mall, and it's only $20. You know, some other conference venues appear to, conferences might be $1,000 or $3,000 to turn up, and so we discussed ad nauseum, what's the price point that we could charge so that we can run the conference and not make a loss. So needless
So
to say.
any small fee, like I used to do some technical readiness delivery for Microsoft, and when it was free, there's a problem because there's no cost for people. So the organiser would front up to deliver a presentation, and there'd be like from a third to 2/3 of the people there, and people were makers and so on. So by having a small fee, the people are parted with something, so there's more liability on what you, regards to numbers and so on that you expect. Charge too much, you might not get too many people, but that's a good one.
Yes, and that's what we thought was, go, and $20 is enough that even if your employer says, we're not funding this, sure, if you want to take the day off to go to the conference, or, and then you can think, well, look, it's $20, it's tax deductible, sure, or a student even, they can come along. And so it's really about bringing everyone together.
So it's a full day?
It's a full day, starting at 9, ending at 5. Assuming we go on time, which I guess we should aim to.
And just the one street, as it's the main, just the main.
At the moment, that's what I'm thinking. Though, if we end up having enough speakers, and I can imagine we may end up with 2 streams. Let's see how many speaking proposals we get, and this is just the first year, so I guess we'll see how we go.
It's interesting, there's a guy, Alex, I can't think of his surname, but he's in a startup with, I think Ender is the name of his cryptocurrency. And he had a number of views of why supply chain wouldn't work on blockchain, and a few others as well. And this one of his presentations, so he gave a thing at Block Conscious, there's a crypto thing last August or something like that. Very interesting conference, some techie areas and then some not so techie.
Well, it'd be great to have some doubters come along and give a talk, as the blockchain skeptic.
It's quite a bright book. I don't think there's contact details in the book, not in this book anyway. Well, if you find it, it would be great to forward it, see if I can.
I'll do that, John. It's early. I'm going to go into a meeting. I'll give you a call afterwards if you want to catch up with your place.
You've got a friend there's QGCIO, he'd probably be interested as well.
Well, I hope so. So thus far, Beef Ledger have come to the party, so we've got Pegasus and Beef Ledger as gold sponsors event, and so it's so we've got that means you're getting engagement from QUT and also the industry and QUT, so that's good. And we've had someone who's from the clothing industry, so nothing to do with blockchain at all, who's already registered, and so some registrations coming in.
Wasn't that lady that
No, it's something different. I know. So, which is great. Isn't it great that we've got multiple people who are in the same sector? And I actually said to that lady, and I said to her, "Hey, there's someone from the clothing industry you know, and given you're trying to, you know, you've got a product which is doing some clothing industry supply chain on blockchain, you should really turn up and maybe put a speaking proposal in, you know, because this could be our customers. Yeah, so it is interesting. Even I've even reached out to some people in Bowen, you know, because you can imagine if you're putting together, I don't know, an aeroplane, whatever, you really want to be able to trace where all the parts come from. I mean, they've probably got some sort of system to do that at the moment.
It's quite sophisticated. Although individual serial numbers, I'm not too sure what goes into what.
Yeah, and I mean, because you could imagine you could have a centralised system for that, but then equally you could imagine you could have a decentralised system where, you know, the whole way out along the supply chain that goes to make that aeroplane, you've got people, you know, vouching.
Actually, Japan is probably a better one because a lot of their manufacturers use local suppliers. So very small.
Only if they're in the same currency.
True, but the cases here that say, you know, building a car, you might have one local supplier that provided the different parts, but you know, the very next car may come from another supplier.
Wow, that'd give you interesting quality issues, you know, because
they're pretty fussy on the quality, but I'm not too sure.
Still, I mean, you can imagine if you've got your parts, you know, some part that's come from one company, and then suddenly you're getting another batch from a different company, then though they will be, you know, almost interchangeable, will they be perfectly interchangeable?
Yeah, I mean, they've been doing it since, that's from the 60s, I think they established that.
No, correctors have been around in Japanese society for over 300 years.
Yeah, sorry, very well maybe, but I was wondering for the car industry taking that aspect on. I didn't think the footprint was there till they started getting the exports in the 60s.
That was when Deming went there.
Sorry, don't know who.
Deming is the founder of quality assurance and quality control.
Right.
He was a professor at Stanford University and went to Japan and improved their quality structure in manufacturing.
Okay, that looks a good one. But anyhow, maybe an example of blockchain.
Yeah.
Supply, as in supply.
Yeah. That should be good. How have you been keeping, Adrian?
Pretty good, just come back from consensus.
Oh yes.
It was good. Much better this year than last year.
Mm-hmm.
Last year, because the price was so high, you had every scam artist you could think of.
Yes.
There was, last year I think they had over 8,500, this time they only had 4,000. A little bit under, might have been a little bit less than 4,000, but good quality. Very good quality.
Yeah.
A lot of VCs there. ICOs didn't even get spoken of. There was only one discussion, which was on an IEO that Binance had done. Bitfinex, right?
Yeah.
They raised some $1 billion in so many days. Well, the rest of it was really good. Very good discussions on regulatory matters right across the world. It was a much better conference this year. They had they didn't get Jay Clayton this year, but they got what's her name, Pearson, who's the standout commissioner on the SEC that's all blockchain and crypto friendly. So they had her on an interesting discussion. What else was there? There was a lot of discussion about the new JP Morgan coin and what it's really trying to do, which was interesting.
Okay. That's good.
So what is it trying to do?
Well, they're building on there was a paper written in the early 2000s by the chief economist for the Chicago Federal Reserve that did an analysis of how much it costs banks to do transactions. And all they're trying to do now is to even reduce that cost even further, by they don't even have to manage the accounts. It'll be your coin, You put the dollars in, they go use the dollars for what they want, but you manage your own account. You have your own account in your own wallet. Okay?
Mm-hmm.
So that end, you'd have to, what they're even charging people to download their wallet, I think, so that they can keep better control over their private key.
Mm.
So, I mean, internet transactions cost the bank approximately 0.01 of a cent.
Mm.
These things are going to go to like 6 decimal places and of a cent.
Yeah.
So they're going to get massive multiples in their profit range. It's the only reason why they're doing it. And the other banks will follow suit. Then there'll be issues of, at the higher level, on real-time settlements with the Federal Reserve on how they're going to swap these coins between the banks. And that's when you'll get the Federal Reserve involved.
Yeah. Mm.
But Diamond still does not like Bitcoin. Or Ether, for that matter. He's allowed his opinion.
Mm. Yep.
You know, I see it that, you know, with what the banks are going to do, it's no different when you go to Hong Kong and you get a Standard Chartered Hong Kong note, or you get a HSBC Hong Kong note.
Mm.
They're both printed by banks, but under the authority of the regulatory organisation.
Yeah, that's all. But I guess in Hong Kong they're all interchangeable.
Well, that's what's going to happen eventually.
Mm.
You'll get the banks where you'll get Wells Fargo being able to swap their coins with JP Morgan or Bank of America or any of the others. But that's down the track. I think it's really just a trial for certain customers at the present moment.
Yeah. It'll be interesting to see how it unfolds.
Oh, without a doubt. I mean, I know that yesterday the Bank International Settlements, the president issued a note on CBDCs, which CBDC, central bank digital currency.
Oh, okay.
Yeah. Which I think is a mistake.
Yeah, so what that would be, what the US issuing their own digital currency.
Converting their physical currency and having the equivalent in a digital arrangement, which I think is a massive security economic mistake.
Yeah, because I guess having a bank go broke because something bad happened.
Oh no, it's worse than that. We don't know how technology is going to be developed. I mean, for many, many years we used to think that RSA, elliptic curve, and discrete logarithm over a finite field were very secure. But as Peter Shaw showed in 1996, they're subject to quantum computing attacks. And now you get Grover's algorithm that's come along in the last 10 years is even more dangerous to those types of things. So we don't know what's going to happen in 30 or 40 years' time, right? And there's a really good study that the Australian Reserve Bank did on physical currency, counterfeit currency. Have a go at the multiple of the damage to the economics is. They monitored $140,000 in $50 notes in the Australian economy. Have a guess what the adverse damage was?
Of counterfeit real currency, almost nothing.
No, $7 million, 50 times.
Okay.
That was the adverse damage to the economic of Australia. Now you think about a digital currency.
Why would that be the
That's
case?
the multiplier effect.
That's the multiplier effect.
But why I mean, if I've got, say, a dodgy, say, $50 note, and I give it to
I can't
you,
argue what the damage,
You know,
how they calculated the damage. I can just, I've got the paper here.
Yeah.
I'd have to go and read it again on how they calculated that damage. But that was the adverse economic damage to Australia's economy, just monitoring $140,000 worth of counterfeit $50 notes.
You know, because you could imagine if a business accepted a whole heap of that currency and then they turn up to the bank to bank it, and then they can't, then, you know, they're out of pocket, they go broke, so that would be a big deal.
Yeah.
But assuming that they're equally distributed across the nation, and you know, you don't keep on.
Well, that's the other thing, they're not equally, that's the hardest part. The thing about physical currency is that it's very hard to distribute mass amounts of it right across the country evenly. But you can do that with digital currency quite easily.
The dilemma of the digital currency is the not only the case of the technology of being able to crack keys or whatever. It's just if there's simply a coding error or a coding exploit. Well, there was a Monero had sort of.
Oh yeah, they had
Was that Monero or was it Zcash where they had the problem and they didn't tell anyone and then they solved it and then announced the correction?
I thought the Monero one was that it was discovered where they put the destination wallet twice, and it basically only debited you once but credited at the other end twice. And
that's a bit of a bug.
and a whole lot of exchanges got hit. They quickly picked up. I don't know how to discover it. So all I'm saying is, you know, something, an oversight or you know, an exploit that something like that could.
And you get state-sponsored organisations that could easily,
Yes.
and you don't have to release massive amounts of it. You only have to undermine the trust in the local society of the jurisdiction to create an economic downturn.
Yeah.
I'm giving a presentation
I know.
on
I'm just, it's just because I remember back about 20 years ago, I was in a nightclub and someone had a plastic. Yeah. So anyway, plastic. Maybe it was even longer ago. Anyway, whatever. So plastic tens had come out quite recently. And
Plastic what?
$10 notes.
That's-
Oh right, okay, yeah.
Yeah. And so someone had a note, and I just picked it up and touched it, and I could feel it. So it was dark, but I could just feel it. I'm thinking, this doesn't feel right. It's too thick. This is too thick. You know, put a bit of light on it. That's definitely a fake. But I think I think they just went to the bar and spent it, and then let the bar deal with it. You know, because they're probably too busy to notice too. But
There's the $100 bills when they first came. They were photocopied.
Don't forget, you have to pay GST on all of that, so there is an economic aspect. You've got a fake $50 bill, which really is valued at nothing, and yet the government is imposing a 10% surcharge on it for the transaction of the goods.
yes, and you've delivered those goods.
And you've delivered those
So
goods.
you've lost your cost price.
Exactly.
Yeah.
So I don't know how they calculated it, but it's an interesting paper by the Reserve Bank.
Yeah.
I'll send you a copy. if you
It'd
want
be
it.
interesting to know also what percentage of transactions happen in cash these days. You know, because surely there's a huge proportion of.
Oh, there's a good paper on that on the Reserve Bank site, on the downturn of cash and the upturn of credit cards and debit cards.
Yeah.
It's actually called the Cashless Society.
Yeah, so we've talked about the digital divide, but you wonder whether there is a credit card or debit card divide. So, you know, poor people people with bad credit rating can't get an account to get a credit card, so they can't tap and pay.
Yeah, I mean, my mother, she died 3 years ago. She was 99, never had a debit card, never had a credit card. She wanted the little book. She'd go into the bank, and Combank would never charge her for it, but she saw the number in the book, walked away with it, and that was her banking.
We should probably get going. I better. Well, right. Let's get going. Alright, hello and welcome everyone. So today's talk is on Ethereum registration authorities. We were having such a good talk here, I bet we've started late, haven't we?
We have, sorry about that.
That's okay, that's okay. Okay, so I'm going to walk you through what problem am I actually trying to solve here. You know, why are we coming up with something new? What the existing solutions are, so if we don't use this, what else could we do? What Ethereum registration authorities are, and then also talk about how this interplays with state rent, and some thoughts on that. So winding back, Ethereum private sidechains, which is the technology that I've been researching for about 1.5, heading towards 2 years now. It's ephemeral, on-demand, permission private, confidential, atomic cross-chain transactions. So ephemeral, you create it, you use it, and then you can archive the blocks on a private network, and having to somehow or other email or telephone someone and say, here's the IP address and here's the key. You can do it on demand. Permissioned, you restrict who can be on the network. Private, you don't want to be leaking the participant list. Confidential, you're going to encrypt the stuff. Atomic cross-chain transactions, you can have multiple chains. The transaction occurs on this one and it does a function call, which then results in it, say, occurring on this one, maybe even another one. Those transactions are either all committed or they're all ignored. So this is the overall technology set. And this Ethereum registration authorities though, and just to solve this little piece here, we want to set up a blockchain between two parties that haven't interacted before, so a permissioned one, a private one. So you've got to think, you want to set up, say myself and Ray, we want to set up a blockchain. Well, actually Ray's a major retailer, and I want to set up a blockchain with him to do some sort of transaction, knowing that he's going to automatically deploy a contract once the private chain's up. So how do I find out what his IP address of his computer is? How do I know about his cryptographic keys? How do we do this? And so, look, working it through. So you can imagine you've got 3 enterprise Ethereum clients that are related to 3 different enterprises, 3 different organizations. And you're the user there. You fire in a request saying, hey, I want to create a blockchain, a private blockchain with these 3 entities. And so it's going to say, hey, address book thing, give me their IP addresses and the cryptographic keys of these organizations, because I want to send a message to them. And then you'll spawn a sidechain client, and then you'll fire off the request to these other sidechain clients. And they'll say, do I accept incoming requests from anyone to set up a sidechain, or am I selected? Are they on my whitelist? Are they on my blacklist? And try and work out whether they want to do that. And they'll look at the messages that have been signed, and in their version of the address book to see, do they agree? Does the message verify? Do they trust it? And then, assuming they do, they'll spawn their clients, and you'll set up a network, and you've suddenly got a private sidechain, a blockchain. And so it's this magic address book that we're really trying to work through. How do you do that? What technology could you use that could give us that? So what are the existing solutions out there? So this is not too far away really from https://example.com. I'm on a web, I've got my little web browser there, I bang that into the web browser, magically I'm seeing a secure page, some content that has come from a computer somewhere or other in the world at some IP address that I don't know about, and it's secure. I can guarantee that that information actually came from that website and not somewhere else. And how that happens is, I exchange the domain name I've got for an IP address using DNS. And then the protocol, the Transport Layer Security Protocol, requires the certificate, the server certificate, to be sent to me. Inside that server certificate is the public key of that server. And then I've got inside my web browser the root CA certificate, which has got the public key, and so I implicitly trust that public key. And then there's this thing called cert path validation, which validates up the tree. So it goes up the list of the chain of certificates to see whether there's a link between that server certificate and that root CA certificate. If there is, then we're all good. And in that certificate, there's a link between the domain name and that public key. So I know that it hasn't been somehow rather changed, and the private key moved from one server to another server, one domain to another domain. So that's how that works. So we could probably use something like that, couldn't we? Well, maybe not. So the problem with domain name registrars and certificate authorities is they're centralized. So, you know, here we are, we're all blockchain, and we're all decentralized, man, and, you know, we're all saving the world by making things censorship resistant in the blockchain. But this thing, which is really the cornerstone of, you know, deploying a private blockchain system, if that's centralized, then the whole thing's centralized. So you've got to try and, you can't have a centralization point.
You have a single point of failure in essence. And plus the certificate authority's root CA is a self-signed certificate which can be spoofed.
Well, not
It's
spoofed.
possible.
What can happen is a hacker can take over
Yeah.
the domain name registrar and use the private key to issue certificates that are dodgy. DigiNotar being a noteworthy case some years back, where they issued Google.com certificates to a bad guy or bad girl. I'm not sure. I'm sure it was a bloke. You know, most of these things are.
Yeah, we're the bad ones.
Yeah. Anyway, but also there you've got censorship problems as well. So a domain name registrar decides it doesn't like the, say, xyz.com.au subdomain, it'll just cut it off. And so if you're the .com.au registrar and you say, I don't like xyz.com.au, you're gone, there's nothing you can do. You're off the internet. And DNSSEC is something which helps make sure that you are talking, you know, have got your authenticated records, and you don't have spoofing, and you don't have DNS poisoning happening. But unfortunately, the deployment of that is incredibly patchy around the world. So some countries it is very high, other countries it's only about 7%. I think in Australia it's something like 30% or something. So yeah, so the way that we do the internet at the moment, https://example.com, censorship resistance, you've got censorship and you've got centralization, which you don't want to have. So other techniques you could possibly use is out-of-band sharing. So essentially, here's a text file, I'll email it to you, and the hash of the text file is this, and then maybe you talk that over the phone, the hash, or something. And so Quorum, Hyperledger Fabric, our own Pantheon, they all use that. So, you know, but that obviously is means that, you know, you can't do an on-demand establishment of a blockchain if you need to communicate that information out of band somehow. And we're actually working on both with this solution and with other ways of doing on-demand creation. You've got Corda has a network map server, so they have a centralization point, or essentially a God view entity which says, this is a new entity in the system, and it just puts it in there. But that means, of course, you've got not only an architectural centralization point where you've got this server that you then go and contact to say, hey, is this entity in the system? But you've also got political centralization because you've got one entity that can add entities to the Corda system. So, you know, the way Corda's doing it is very centralized. IPFS's IPNS, so their naming system. So IPFS, all the addresses are essentially like random numbers, essentially. But if you want to have a fixed name that points to one of them, so you can upgrade the data, because the address is related to the hash of the data. So if you change one part of the data in IPFS, then the address changes. So you can have IPNS, which points to the current IPFS page. And so their idea is to use DNS-TXT records. So DNS records have like IP being the IP address, A being the IP address, and a whole heap of other records, and one of them is TXT. And so you can put random data, text data, into these records. And so that's what Monero and IPFS use. Obviously, if we're worried about centralization and censorship issues, then using DNS-TXT records isn't good. And as well, DNSSEC is not widely deployed, so you may end up with not the right value. Namecoin is a blockchain technology. It's one of the first forks of Bitcoin. And so it's been around for years, and it's specifically aiming at storing name information. The problem with it is it's not secure anymore. It relied on merged mining to have its security. So in other words, you include the hash of the transactions in the Bitcoin blockchain, and in that way you get this leverage the security of Bitcoin. But then the Bitcoin miners stopped mining Namecoin, so there's only one miner for the whole of Namecoin. If you've got 100% of the mining done by one miner, then it's not secure anymore, because they can revert history, do all sorts of things. So trying to go and have your very own blockchain is not going to be a good idea. So you've really got to leverage Ethereum or some other major public blockchain, so you get the security. So FDNS uses ENS, so ENS is Ethereum name service, and it allows you to associate names with values, and there's a hierarchy as well within it. But the issue that I felt that they had is that you need to be able to have multiple trust groupings. And by this, what I mean is that you want to be able to have, say, the Adrian registrar, and so we all sign up and register our domain or our information with him. But then, so that just in case Adrian stops liking us and wants to censor us, we also register with Ray. But then, because I'm a bank, maybe the Reserve Bank of Australia says, we are going to be the authoritative list on who is a valid bank, and so we're going to have a list of all banks that are valid in Australia. And when you want to establish a private blockchain with a bank in Australia, you look at our ERA, our registrar, and if they're not in our list, they're not a real bank. So you can not worry about them. So that gives you multiple trust domains. And so that was one thing that I thought was very important when designing this. And so the FDNS system, there is one trust level, which is everything. And as well as the different types of information, like the Reserve Bank versus two different registrars, the other thing might be that Ray here, he might do really good anti-money laundering and so AML and KYC, know your customer. He might be really good at that. Whereas Adrian, you being a relaxed guy, you might just run a social, one. So essentially, Sandra says she knows Peter, and Horacio says he knows Peter, and then you say, well, look, if
sounds like the Web of Trust that was put out by PGP many years ago.
Well, yeah, and you could do that. I mean, that has been put forth as a way of doing things, and there is a level of validity. If you've got 5 people who are deemed valid, say that you're valid, then maybe you are. I mean, is it any better than you going to a bank and them trying to, come up with something to say you're valid? So, yeah, there is some validity to it, but still, you can imagine they're two different types of trust groupings. Ray's gone to the effort of finding out if I've got a registered company at that address, and maybe we've done a video call, and he's made sure that I'm a real person. So there's a different level of assurance. You can imagine you want a different level of trust grouping. So, from what I can see, we've got no bootstrapping technique, which is decentralized, gives you the censorship resistance that you need, and allows you to have multiple trust groupings, and also the data stored securely. So, ERAs. So the idea is to store information based on domain names, so IP addresses and cryptographic keys, but it could be anything. It ends up boiling down to a name value pair, and you store it on a coordination blockchain. Now the coordination blockchain could be any blockchain, but you might choose it to be Ethereum mainnet. And if you do, then you get authenticity, integrity, and non-repudiation. So you're pretty sure that once the value, you're pretty sure you know who published the value, you're pretty sure that the data that's there hasn't been changed, and you're pretty sure that the data that's been there is locked in and can't be altered, can't be reverted in some way. And the code for this is on that GitHub repo, and these slides are available on the Slack workspace, and there's a link to it on the meetup page. So there are 3 main Solidity files overall, Solidity interfaces. The first one that I'll talk you through is domain info. And so essentially, all it is a name value pair. So you go set value, you give it a key and a value, and you can delete the value, you can get the value back, and also you can get the version of this contract. So essentially, you know what version of the Solidity code you're looking at, just in case there are multiple versions in the overall system. So you can set a name value pair or key value pair, you get a value based on a key. And the key is the message digest of the domain name, colon, the key type. And so you might have, say, sc.example.com as the domain name, and then the type of key that you're interested in could be address. And so if you do that hash and put that in as the key type, then you would be selecting that domain with that type of information. And so it's a way of storing information in the system based on a broad set of domain and value pairs. And in particular, if you have star that says any domain that's in this domain info contract. So the idea is you have multiple domains or information relating to multiple domains within the one contract, but then some information that you have, like say the email address that you should address queries to that relate to this domain, maybe they pertain to all of the domains that are held in that domain info contract. So why repeat the information? It would be easier just to have star. So the other contract is are there any questions about domain info? Clear as mud? Cool.
I have one question. Is there an idea to allow stars at any depth through the DNS-like path?
Yeah.
To mirror the ability to be able to point at any particular part along the path.
You can, but you'll see why why you don't just at that level for the key value pair you just do star.
Yeah.
But it'll make sense when you have a look at it. Yeah. Okay. So for the ERA contract itself, there's add update domain. So we either want to add a domain to the system or we want to update an existing one. And so you've got something called the domain hash, which is the hash of this subdomain, the address of another ERA contract. So you can have a root ERA which points to a sub ERA which points to another sub ERA, the address of a domain info contract, so the contract that we previously talked about that had the key value pairs in, and the domain owner. So for these last three fields, they're all optional, and so you might just be saying we've got a delegate authority, you might just be saying we've got a domain info address, and if you don't specify the domain owner, then it is the owner of the overall contract. The reason for having these optional values is that everything's very much keyed towards minimum gas cost, and so you don't want to be expending lots of gas and lots of ether when you're deploying this technology. So yeah. There's also a remove domain, so which only the contract owner can execute. And then there are a whole lot of getters. So you give it the domain hash and you get various information back. And so you could imagine you could end up with something that looks a little bit like this. So you've got two root ERAs there, A and B, and example.com is in both of those. So they've registered to be in both of those, and they could be in any number or none. They don't have to be in any, so they could be themselves essentially like a self-signed certificate. They could be the root ERA themselves, or they could choose to register in a root ERA. And so the difference between a root ERA and a delegate one is nothing except a logical view. The actual code itself is identical. And below there you've got two subdomains, and they've got two completely separate domain info contracts. And then, as you can see here for bank.co.uk, you've got a domain info as being listed directly in a root ERA, and you can do that. So supply.com, they have aa.supply.com, and then they refer to themselves, so they're actually saying, I am the authority for my subdomains. And so then they've got the subdomains, and both A1 and A2 are resolved here. So similarly, so aa.supply.com could have also had a domain info which was separate, so any star that was at that level would have been applied to it. And then I showed for edu.au a very long set of delegate authorities. So the thing to think about is that with the, here, you could have the edu.au, which is this one here. So that could be run by some government authority. edu.au as a domain must be run by some big, registrar. And then this ERA here could be run by University of Queensland, uq.edu.au. So it could have all of the departments have registered, and then they could say, look, electrical engineering department, we just don't want to know how you organise your stuff. Here is your domain info contract. Go and administer that yourself. So it allows a great deal of delegation of administration. And for that matter though, this domain info, if they really wanted to, these people down here, they could register with root ERA, so the first one, directly if they wanted to. There's nothing to stop them.
Peter, so the thing to stop DNS spoofing here is use of keys.
The thing to stop DNS spoofing is, so in other words, you claiming edu.au and
as I do occasionally.
As you do occasionally, yeah. Is that the ERA over there is going to have a look and say, I don't know that I trust that David really is this, and I've got my reputation on the line, and all these people are paying me money to be registered here, and no one's going to trust my Ethereum registration authority if I register something, some entity that's not real. Yeah. So though I have drawn all of this with
would they get to know that though? Wouldn't their visibility initially only be, if I miss something, the edu, AU?
Yeah, well, sure. But if for instance, these people wanted to register directly with them, which they can choose to do, they have to do their due diligence. But yes, you're right. These people would only be doing their due diligence against edu.au, and then it would go down. Yeah. Right. I've got a few call-outs that Alright. And then the third type of contract. So when you've got, so if you've got if this is on Ethereum mainnet, or even on say Rinkeby or some other network, every time you do a call to a get or a view to get a value back, it takes time. And so if you wanted to say to this ERA, or have you heard of have you heard of itee.uq.edu.au or any of the subdomain or parent domains, then if you're going to do one call after another, if you end up doing say 500 calls to get to here, say, that's going to be a lot of interaction. It's going to take a long time. It's not going to cost you anything because they're view calls, but you're going to burn a lot of time doing lots of requests. So the finder contract, you do one single call here and say, hey, this is what I'm looking for. Can you please find the domain info contract for this domain? And so that's its whole purpose, is you do one single call and then it does all of the requests internally. within a Solidity contract. So we've got resolved domain, and so you've got your list of ERAs that you trust, that you want to, so your ones that you're deeming to be root ERAs, and then you've got domain hash, the parent's parent, and the parent's parent's parent. So essentially you're trying to find this domain hash inside these ERAs or their delegates, and you might supply additional parent information as well. So for instance, you say if you were after aa.sc.sales.example.com, you pass in the message digest of it there, and then you might decide that you want to, you're happy to just find example.com as a start, and then use it to find those subdomains. And so you pass those parameters in, and that would allow you either find that one directly, or find it via that one, find it via that one, or find it via that one. And you could choose though, you don't have to have all of these parameters set. And so if you might say, look, I only want to match on example.com, so I don't trust just finding .com. I actually want to find example.com and not use registrars that have just got .com, because I'm not sure that I trust that level down the tree. There's also another function which allows you to resolve multiple domains at once. Due to the limitations of Solidity though, you need to return back from Solidity a fixed length array of data, and so it's hard coded at 10. So you'll get records back as if you're getting 10 sets of 10 addresses back, of which maybe only one or two will be set. So the number will be set based on the number of domains that we're searching for. And so we've also got some wrapper code as well written to go against Web3J, and also some test code as well. So you end up with this, Ethereum registration authorities on each, and so it's going to go and say, hey, this is the domains that I want to contact. Can you give me the domain info, which will give me the IP addresses? From the IP addresses and the keys, you're then able to set up your connections, and you'll be able to establish, and then they'll check who it's coming from based on gathering information out of their ERA. Okay, so Brett, who is not in this room at the moment, but he did a talk on state rent back a couple of months ago. And so so it's an Ethereum 1.x work stream, which essentially says, look, the state tree is growing really fast and we need to deal with this. And how we might deal with this is by charging money, charging gas, to have data stored in the blockchain based on the amount of data that's being stored. So if you've got a contract with heaps and heaps of data and large code, then it attracts a higher cost than if it's small. Yeah, so that's something.
Peter,
Yep.
sorry, is the amount of storage necessary to run a node currently increasing faster than the amount of storage that's economical on a fairly stocked machine? I think the answer to that is yes.
Yes, I think it's yes too.
And do you have a feel for how much?
It's large.
Like in terms of orders of magnitude?
I thought that to run a full node you needed, in the tens of gigabytes of RAM, didn't you? Something like that. I don't know. No, we've got a shake of a head there. How many gig?
I don't think that's true, but I think it is true that the total state storage is approaching a terabyte.
Yeah, I've heard that. How much RAM do we need?
Mainnet?
Yeah, for mainnet if you're running Pantheon.
Adrian was here, I'd say, different Adrian, sorry.
That's good.
I believe you can get away on like 16 gig without issue.
Oh, okay.
On the enterprise networks, you run hundreds of megs.
Okay. Oh, well, that's
CD is
yeah. For enterprise networks are different though.
Yeah, on our implementation, RxDB is pretty good at swapping pages in and out. You don't need it all in memory. So you
Okay.
can probably run it on significantly less memory anyway. The big one is that you need enough disk space to fetch the T of storage.
Mm-hmm.
But you don't need the memory to match it.
Yeah, and so this will, so I guess as you're expanding out beyond 1 terabyte, then that must, I think you're having speed issues, is my recollection of what Brett was saying. So contracts which hold large amounts of data and aren't really owned by anyone, so you've registered your data in there, like with ENS, but no one really owns it. And there's certainly no money in the contract, so there's no way of paying rent. But even if there was a way of paying rent out of the contract, who's going to pay? And how's it going to work? So these style of contracts don't seem to be really set up for, or obviously weren't created with rent in mind, and so they are likely to face some problems. And I don't know what the solution is, but so the Ethereum registration contracts, one of the things that I've been thinking about with respect to rent is the entity that owns the contract owns the data in them. So whether you're a registration authority with a list of entities that you've registered, or you're holding a domain info contract, or you're an organisation with your very own ERA, you own your data, and so you're incentivised to put money in to keep that data on the mainnet. However, right at the moment, there's no way, these contracts as written cannot receive data, or rather cannot receive money. You can't send ether to them. There's no payable function, so there's no way of actually giving it money right at the moment. So it would need to be upgraded once the actual specifics of state rent become finalised. But it, I think, is in a better position than ENS. Okay, and so before we hit questions, I'll just quickly tell you about some forthcoming events. So we've got Chris Mackay is going to tell us all about Enterprise Ethereum permissioning in 2 weeks' time. And not only is he going to tell us about it, but it's going to happen in the other room, the classroom. So we're not going to be holding the meetups in this room anymore. We're going to hold them in the classroom, which is just near the staircase. And you'll still need to go in by reception, but and that's booked out to the end of the year. So you change again. Roberta is going to tell us about consensus protocols. Adrian is going to talk about ClassSync, and then on July the 15th, we're actually having a conference at Fishburner's event space. It's a full-day conference. It's only a $20 ticket. The call for speakers is currently open, so if you get accepted as a speaker, you could save yourself $20 as well, because we've decided that we'll waive the ticket price if you're an accepted speaker. And we've even done a small investment and got a nice small domain name. So it's SC Supply Chain on Blockchain Conference, so SCOBC.net. Yeah, so the idea is that you've got all different types of supply chain. You've got the provenance stuff, knowing where stuff's come from. You've got supply chain financing, so trying to finance the second, third, and fourth tier financiers, so upstream, yep, we're going in the right direction here. Upstream finances, so people, if you supply directly to Coles, then everyone's heard of Coles, and you're probably pretty good to go for getting finance. But if you're the supplier which supplies to that supplier, you often have great difficulty getting finance. So blockchain may help resolve some of those problems. There's also logistics. So you are moving some stuff inside a container, and you then ship that container overseas. So how do you know what's in what container? And if you want to have a shared database, so say you might have a special type of container, and so there's a lot of money being lost where, say you have a a container will leave, go out to Toowoomba somewhere, and it'll get there and it's the wrong sort of container, and you've got all this fresh produce ready to go into the refrigerated container, but you've sent the wrong type of container, and so that they then need to go back to the Port of Brisbane, then turn around and come back again. So huge amounts of wastage that could be potentially fixed with blockchain. And there's automatic deal negotiation, so essentially having robotic negotiation of deals on the blockchain. So we're aiming to get people from academia, from business, government, so developers, supply chain people, and lawyers, everyone together, and to really hammer out and discuss and understand everyone's perspectives and really try to make this whole thing work, and use some of the technologies that we've come up with in the blockchain space to really move the business along. I've done a lot of talking. So, questions? Thoughts?
How do you envisage bootstrapping your bootstrap? How would you envisage people being aware of ERAs that exist?
How is it gonna start? I would have thought that. So I know of 2 separate enterprise deployments that have occurred, and they have essentially put together their own ERA style system to do a registration authority of members and trying to store key value pair data information so that there's a way on the blockchain, so they think, oh, we need a shared database for all this information. We've got this blockchain that we're using to communicate. Why don't we actually put it on there? So I know of 2 organisations, 2 completely separate systems now that have essentially reinvented this wheel. So I imagine that at some point we will have enterprise deployments that will use this technology, and then once you've got, say, a large enterprise deployment, say, I don't know, the Australian government, they're apparently getting into blockchain, I've heard, and so if they get into blockchain and they decide we need a registration authority, and then they end up using it, then if you have enough large organisations using it, then maybe it will be pushed out when people say, actually, this would be so much more efficient if it's actually on mainnet, and then it could go from there. That's how I see it evolving, but who knows?
Well, it's more the question that I had is more about how would I know the address to put in the initial starting point to say that I know that this address is going to be pointing at an ERA that I can use.
Yeah. Well, I guess how your starting point would have to be that you would have to know about that that address, and you're saying, so how would you know if the Reserve Bank has on its website, here's the address, how do you, given all the problems we've just said that you've got with the internet, how do you know to trust it? Do you have to ring up someone and say, what's the hash of that web page? We'll just read it out over the phone. Yes, that is a problem, but then maybe what you could do is similar to web browsers. How that's solved in a web browser is you've got hard-coded keys that are inside your web browser. So if you have a root of trust, and inside of Ethereum clients, there's all sorts of hard-coded information, and so you can imagine this could evolve into like your root nodes that you've got in Ethereum. They're hard-coded in, so you can imagine this also could be some hard-coded information. Good question.
Maybe you could establish a new namespace on the DNS and have that something .DNS or something like that, and then there'd be just like the trusted CAs that you have around the place, and then all the namespaces could be underneath that, and they could even give you a further registration chain.
That's possible. I think, so for myself, I think that I could imagine that people might put, like say, use their actual domain, but then have below it, say, SC dot, and the idea is that they might not have any general stuff that's in DNS at the moment, because the interplay between DNS information that's already there and this is interesting. And I know if you can do a web search on DNS to see some of the things that they've worked through to try and get it to happen. And yeah, I'm not sure that as an initial replacement for that it would work, but then the whole reason for using domains at all is because you know, right, the name of that company is that, so the way I can find out, the information. So it's really an information finding tool. Anyway, so thank you everyone for coming along. Please consider putting a speaking proposal in for the conference, and if you don't do that, definitely come along and pay the $20 and be there for the conference. It's a one-day conference on a Monday, and I think it's going to be awesome. All right, thank you.